We know that to join two metal plates, heat and pressure is applied wherever necessary. Thus we can say that heat and pressure are the two factors on which the welding of metal depends. On the basis of these two factors, welding process can be classified as fusion welding and pressure welding. Let's first understand what fusion welding is. Let us join these two metal plates along their edges. First, place the welding torch and filler rod above the edges of the plates and start the welding process. We see that due to heat from the welding torch, a large pool of molten metal is formed. This pool consists of the molten metal from the metal plates and the filler rod. Now, as the welding torch and filler rod proceed along the edges of the plates, the pool of molten metal solidifies. This process of welding the metal plates by applying heat on them is termed as fusion welding. Thus, fusion welding refers to the welding process where the workpieces are welded by applying heat. Now let us understand what pressure welding is. Let us join these two metal plates. To join these metal plates, follow the same process as in fusion welding. Then at the end, apply some mechanical force on the plates towards the weld joint. Due to force, we see that a pressure acts on the weld and this makes the joint stronger. This process of welding the metal plates by applying heat and pressure on them is termed as pressure welding. Thus, pressure welding refers to the welding process where the workpieces are welded by applying heat and pressure. Fusion welding process obtains heat from the energy ray, low temperature sources, electric arc, and other chemical energy. And pressure welding process obtains heat from the smith's forge, electrical energy, mechanical energy, and chemical reactions. On the basis of the heat source, fusion welding is further classified as, and pressure welding is classified as,
When the arc is struck, it almost instantly creates a temperature of about 6,500 degrees Fahrenheit. This melts both the base metal and the metal in the electrode. The metal from the electrode is melted off in tiny droplets, is carried across the arc and mixed with the molten base metal. The force of the arc and the forward travel of the electrode causes the mixed molten metal to be pushed to the rear of the crater, where it cools to form a bead. The movement of this metal toward the rear of the crater and the depth of the crater are an excellent check on the quality of the work. The operator should learn to use it as his guide. At the same time that the metal is melting, the coating on the electrode is being consumed. This takes place slower than the melting of the electrode, which shields the arc and helps direct the flow of metal. It also permits the use of higher currents, with the resultant faster deposit of weld metal. A gas is formed, covering the arc with a protective shield that prevents the exposure of the molten metal to the air and therefore prevents the formation of harmful oxides and nitrides in the deposit. Also from the coating, chemicals acting as cleansing agents enter into the metal to help to remove the impurities. These chemicals with the impurities float to the top and, cooling, form a coating or slag over the bead.